Hello Algebra 1 students, welcome to the Unit 2 review packet. We are looking at linear functions here and getting ready for our test. If you're one of my students preparing yourself, thank you for coming and watching the video, and hopefully you'll get the help you need here. If you are one of my students, still need extra help, make sure you're coming in before or after school to get the help that you need. Let's get started, let's get right into it. So Allison is making a square herb garden. She wants to put a border around the garden using square concrete tiles. The border is to be 1 tile wide, and the table below shows or gives the total number of tiles needed for a given edge width. So really what's going on here, if we have 3 tiles around an edge, if you are a visual person, we would have something like that. 3 tiles for the border. The border edge length there is 1, 2, 3. But that would take 8 tiles around the border in all. If your edge was 4, it would look like this. But if you count all those tiles up, I got 1 too few there. If you count all those tiles up, it's a big tile there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where these numbers are coming from. So we could continue that pattern out there. But to write a rule, that means write an equation for the total number of tiles around Allison's herb garden when n tiles are used along the edge. So really we're just looking at this table and coming up with the slope. This is like my x and this is like my y. My t value, total tiles, will depend on the n value, the number of tiles along the edge. And if I look at the slope here, it looks like I'm going up 1 for the x values every time I go up 4 for the y value. So this is a linear pattern. The pattern is consistent. The pattern is proportional. So we can say the change in y over the change in x, that's the slope. That is 4 over 1, or just 4. From there, to come up with an equation or a rule, we just need to take the slope and pick one of the points. So why don't I circle that? I'll use red to show you what I'm doing from here. So I'm taking that and I'm taking that, and I'm using point slope form. We're going to use this over and over again in our preparation for the test. This will show up over and over again on the test. So point slope form, taking a point, I'm going to pick 3, 8. I could have picked any one of these 4 points, but I'm going to go with that one and taking this as my slope value. So this is my x1. Here, this is my y1, my first x coordinate that I picked, my first y coordinate that I picked, my slope value right there, and I just plug that into point slope form. So y minus 8 is representing the y value, and this would be equal to the m value, 4, times x minus 3. From there, distribute the 4. We want to solve for y. We want to have our equation in terms of y in the end. So if I distribute that 4 through to both parts, I will have this, and then if I add 8 to both sides here and here, looks like that's y equals 4x minus 12. However, my final answer should be in terms of n and t of n. So we've got t and n. So this final answer would be t of n, function notation, t of n, total number of tiles given n tiles along the edge, is going to equal 4 times n minus 12. Notice instead of y I have t of n, instead of x I just have n. That would be my final equation, my final rule. If Allison decides she will need 20 tiles along an edge, so we're thinking of this but expand it out to 20, I don't want to draw that picture and do all that and figure out how many that is. I just want to use my formula, my equation, to do that. So if I plug that in, it would be t of 20. This is the number of tiles along the edge. This is where n equals 20. That top value would be 20. I definitely don't want to extend my table out to 20 either. That's why we have equations, so we can use those to predict or determine the value of the larger numbers. So t of 20 would be 4 times 20 minus 12. That would be, looks like 80. I made a mistake here. Ooh, let me catch that. So up here I added 8. I forgot to do that here. So this actually should have been a, looks like a 4 right there. Yeah. Because if I plug in 3 in 4, and 3 times 4 is 12, minus 4 is 8. So there we go, fix that. So that should be a 4 right there. So if I subtract 4 from 80, that's 76. This would be tiles along the edge. Or the total tiles. I mean, the 20 is the tiles along the edge. So it's 76 total tiles. And then from there, number 3, William decides to use the same pattern, but he has 196 tiles. So this is the total number of tiles this time. How many tiles will he have along one of the edges? So this is the total. This is my t of n value right here. This is my t of n value is equal to 196. So in this case, I use my equation right here, but I'm going to replace this with 196, not the n value. I'm going to figure out what n is given 196 total tiles. So this is 4 times n minus 4. Looks like I can add 4 to both sides. That gets me 200 equals 4n, and I can divide both sides by 4 from there. So it looks like that gives me 50 equals n. So this would be 50 tiles along the edge. And so I'm just going to say 50 tiles. That'll be sufficient for my units there. So 50 tiles along the edge is what I would have. Moving on to our next batch of questions for 4 through 7. We actually had changed that to 4 through 8 because there was no number 6 on the original copy. So just make that correction. We're going to make a table for each pattern, find the equation. So I'm going to make an XY table here. I'll make this one horizontal. So X and Y. And on this one, we have 3 points given to us. We have that point, and that point drawn on there, meaning that those points are actually on the grid lines that you see there. This one's a little lower than that grid line right there. So if we're going to use -3, that's not actually quite a point on the line. We want to use the dots that are there. So -5, 4 would be the leftmost x and y value, and I always move left to right. I think that makes it easiest to fill in the table, easiest to figure out the slope, easiest to do rise over run later as well when we have to do that. Looks like that is 0, 1 for that second point, and this one is 5, 2. Always go left or right first for your x coordinate, and then up or down for your y coordinate. From there, it looks like I have a slope that remains consistent as I go through because it's a line. That should be the case. I'm adding 5 each time. Adding 5 here, adding 5 here. Here I'm subtracting 3 to go from the one number to the next. So my change in y over my change in x, that's my slope, is -3 over 5. And if that's my slope and I have a point here, I'm going to go with this point right here. I have that as a point. I have this as my slope. I'm going to use point slope again. Y minus y1 equals m times x minus x1. And so that leaves me with y minus 1 equals the slope, -3/5 times x minus 0. And it looks like I do want to get this to find the equation. I want to get that in terms of y, just y by itself. With this 0 here, this would actually drop out. So I could think of distributing that through, but the 0 part will just go away. So I really just have y minus 1 equals -3/5 x left. And from there, I can add 1 to both sides to get y by itself. So you are going to be required to use point slope form to do this kind of work, to use the table first to find your slope and then plug it into point slope. I know a lot of you may look at that and you can use slope-intercept form to figure out the equation as well, but you're going to be required to use point slope form so that you can demonstrate that you know how to do that using a table, using point slope form to get to that equation. So let's use slope-intercept though just to check our equation. This is slope and the y-intercept. Does it actually cross at 1? It does, like it should. Does it go down 3 and right 5? Like this slope indicates right there? And yep, it certainly does. So let's take a look at number 5. So we're going to use toothpicks on this one. This is my first shape, and it looks like it would have 1, 2, 3, 4, 5 toothpicks to make up that shape. This second shape has the 5 there plus an extra 1, 2, 3, 4. We are not going to double count that one. We don't need an extra toothpick for that. So that's 9. And the third one here it would have the 9 for all that plus an extra 1, 2, 3, 4 there. That's going to be 13 in that one. So if I make a table, I'll go with a vertical table this time. Vertical or horizontal, both are okay. But 1, 2, and 3 would be the shape number, and then looks like 5 matches with 1, 9 with 2, and 13 with 3. So from there, I can find my slope. I can do my change in y over my change in x. Looks like it's going up 4 every time I go up 1 here. So that's going to be my slope. Change in y over change in x is 4 over 1, which just equals 4. So now I have a point. I have 3 points. I can pick any one of those 3 points. I'm going to pick what I think is the easiest one to deal with, though. And then plug that and this into point slope form. You have y minus y1 is 5, if we pick that point, equals 4 times x minus x1 is 1. If you chose 2 and 9 instead, plug those in here and there. If you chose 3 and 13 instead, plug those in there and there. You should get the same thing, though, in the end. So on this one, we do need to distribute. This isn't going to go away like it did here because it's not 0. This would be y minus 5 equals 4x minus 4. And then if you add 5 to both sides, you'll get y by itself, like you should have in the end as you're doing these kinds of questions, these kinds of problems. In the end, I want to see that you've converted point slope to slope-intercept form. So this would be 4x plus 1. And this one and the previous one, neither one said that you had to be in function notation, so we can just leave it as x and y. Instead of, like we did here, we had t of n equals 4n minus 4, replacing the x and y. You don't have to do that here since it doesn't say so. And then number 6, there is no number 6. That was a typo on the copy. So let's just look at number 7 now. And this one, there's already a table, so no need to make another table if there's already a table. And what's my change in x? It looks like I'm adding 2 every time. So plus 2, plus 2, plus 2. And then my change in y looks like I'm subtracting 12 each time there. And so my change in y over change in x, the consistent slope there is negative 12 for the change in y divided by 2 for the change in x. That's going to be a slope of negative 6 if I reduce that down. So here's my point, or here's my slope, and then I can pick any one of these 3 points. To me, the 3 and the 18s look a little harder to deal with than the 1s and the 6s, and I'm going to go with this one. I could have picked this one as well. I could have picked any one of those 4 points. They all would have worked just fine. So y minus y1, my y value that I picked is 6. So y minus 6 equals the slope, negative 6, times the quantity of x minus negative 1. So if you want to write it like that first, you can. If you want to just go right to this step, that's okay too, where you change the minus and negative to just a positive. And then from there, distribute your negative 6 to both parts. That leaves you with y minus 6 equals negative 6x minus 6. If you add 6 to both sides, that will get rid of the 6 right there, and it will happen to cancel both of them on both sides, leaving you with y equals negative 6x. That's our final equation. If you check that against your table like you should, it should work out. So if we plug in negative 3 for x, negative 3 times negative 6 is in fact positive 18. You can keep doing that with your x values here. And if you plug in negative 1, you get positive 6 for the y value. Same thing with 1, you get negative 6. With 3, you get negative 18. You can do that with these equations as well. We did that, or we could do that with this one. Check your x values by plugging them into your equation and see if it spits out the right y value. If it does, you know you have the right equation. From there, number 8, this one, we're going to use these as our x values, and then the total number of tiles as our y values. So 2 looks like here, and you have 6 squares tiles, 10, 14. So our table would look like this. X and Y would be 1, 2, 3, and 4 would match up with 2, 6, 10, and 14. And from there, it looks like I have another 4 over 1 as my slope. And that's okay. I will have a different point, though, that I'll be picking here. So that's my change in y over change in x. That's my slope value, 4 over 1, which equals 4. And from there, let's use that as our slope. We're using that in y minus y1 equals m times x minus x1, point slope. So let's use that value, and I'm going to pick the easiest one, or what I think is the easiest one to deal with, 1, 2. I could have picked any of those other 3 points as well, but might as well make this as easy as possible. So y minus y1, y minus 2 equals 4. The slope times x minus x1 is 1. Distribute that 4 through. You've got y minus 2 equals 4x minus 4. And then add 2 to both sides. And the 2's will cancel there and there. You're left with y equals 4x minus 2. And again, no function notation is necessary. You're not required to do that in the directions to the problems. So we can just leave it like that. If you check that against your values, 4 times 2 is 8 minus 2. What I meant to say there, I meant to plug in this. 4 times 1 is 4 minus 2 is 2. 4 times 2 is 8 minus 2 is 6. Same thing, 4 times 3 minus 2 is 10. 4 times 4 minus 2 is 14. So that all checks out against your table values. Let's take a look at number 9 and 10 now. These ones go together. What's your independent and dependent variable? And then find the rate of change on each one of these. So the average adult breathes in about 37 liters of air every 5 minutes. What is the rate of change? When you see that phrase, you should always be thinking, what is the slope? So what's your change in y over your change in x? And the y always depends on the x. So what makes more sense here to say? What would make more sense? To say 37 liters every 5 minutes, or 5 minutes every 37 liters? 37 liters per minute per 5 minutes? To say liters per minute or minutes per liter? That's really what you're asking yourself here. What makes more sense? Liters per minute, I think, definitely makes more sense. So our rate of change, our change in y over the change in x, is going to be the change in liters over the change in minutes. And if that's the case, liters is on the top. That's like your y value. That is the dependent value. That depends on how many minutes you've been breathing for, or the adult has been breathing for. So the dependent variable is liters, and liters depends on minutes, the independent variable. So your y is always dependent upon the x. Here, liters is your y, minutes is your x. And so we have the change in liters was 37 liters every 5 minutes. Since that is not a reducible fraction, you could have that as a final answer. I would totally accept that as a final answer if you're one of my students. Or if you put that into a calculator, you would get, looks like that would be, 7.4? Yeah, so that'd be 7.4 liters per minute. That's another way to say the same thing. So I'd accept either one of those answers. Down here we have Shelley delivering newspapers, 10 newspapers after 30 minutes, 24 after 72. So on this one, your change in y over your change in x. Think about what makes more sense, to say the change in papers per minute. Does that make more sense? Or the minutes per paper? What makes more sense to say? I would definitely say newspapers per minute delivered, not minutes per newspaper. So newspapers, change in newspapers over the change in minutes. So that means newspapers depends upon minutes. Newspapers is the dependent variable because it depends upon how many minutes you've been delivering for. And so this would be, if we have 10 after 30 and 24 after 72, My change in newspapers is 24 minus 10. My change in minutes is 72 minus 30. If I reduce that down or simplify that, that's 14 over 42. And if I reduce that, I can divide both of those by 2. I could also divide both of those by 7. And I could most efficiently divide both of those by 14. I could do that and break it down into steps. If I didn't see that 14 went into both of those, I could divide by 2 or 7 first and then divide by what I still could divide by after that. But it's one newspaper, fully reduced, one newspaper every 3 minutes. And that is your final answer, so you could box that in. If you said 0.3 repeating newspapers per minute, I'd accept that too, because that's what 1 divided by 3 is. So 0.3 repeating newspapers per minute would also be an okay answer. Moving on from there, number 11 now. We have a 11, 12, and 13 using this graph. A remote-controlled car moves in a line. The graph below shows the distance d in feet of a remote-controlled car from the person controlling it t seconds after turning it on. So this is representing seconds, it looks like, along this axis. And then this is representing the distance in feet along the y-axis here. So let's look at each segment of the graph. If you fill in the table, segment C, that's from here to there. So from there to there, what's the interval that we're looking at here? It looks like we're going from 3.5 up to 5.5. That's the interval in question. So the A value where you start is 3.5, and that goes all the way up to 5.5. So that's the potential x values along that segment. Your change in y, think of that as rise over run. You are dropping down by 5, so that's a negative 5, and then you are going over by, we're going from 3.5 to 5.5. That's a difference of 2. So my change in y, it's going down 5, minus 5. My change in x, it's going to the right 2. That's a positive 2. So from there, you could either write negative 5 over 2 and say that would be feet per second, or you could write that as a decimal. Negative 2.5 feet per second would also work. So either one of those would be okay, but I need to see, just like it says here, include units. So I would take that or that, but make sure you have feet per second on either one you choose. If you do this, it's negative 5 feet over 2 seconds. For D, I'll use red for D, so I'm going from here to here. 5.5 to 6.5 this time is my interval. The change in y, well, there is no change in y. It doesn't go up or down at all, so that would be a 0. And the change in x, it's going up from 5.5 to 6.5. That's 1 right there. The slope, if there's no change in y, is a 0 on the top. 0 divided by 1 is just 0. So my slope there would be 0 feet per second. There is no change in feet. And then I'll go green on this last one. So from there to there is going to be segment E. That's going from 6.5 to 8. That change in y, looks like we're going up from 10 to 20. That's a change of 10. And then we're going to the right from 6.5 to 8. That's a change of 1.5. So a change in y is 10. Change in x is 1.5. That would be 10 over 1.5, which as a decimal, that would equal 6.6 repeating feet per second. And that is a positive slope. So definitely a positive number right there. We're going uphill as we move left to right, not downhill. Let's take a look at 14 and 15. Now we're going to do some graphing. On these ones, the instructions are saying to find 3 points that satisfy each equation using an XY table, and then plot the line on the coordinate graph. So x plus y equals 4. I meant to say x plus 4y equals 4 there. So I have my table, xy table. First I would want to solve for y. That's going to make life a lot easier if I do that. So I'm going to subtract x from both sides. I'm trying to get this portion by itself first. So get the 4y by itself first. To do that, I can subtract x from both sides. That leaves me with 4y, positive 4y, equals negative x plus 4. I'm going to write the x part first because that will be in slope-intercept form, which we'll continue to use as the lesson goes along here, as the review packet goes along. If I divide everything by 4, that 4 would cancel there and there. I'm just left with y equals, this is like a negative 1 right there. It's like there's an invisible 1, so that's negative 1/4 times x, negative 1/4 x, plus, and then 4 divided by 4 is 1. So I'm going to use this equation to come up with an xy table. So my x value and my corresponding y value I'll put there and there. If you plug in 0, that's a really easy one to plug in because this part, negative 1/4 times 0, will just drop out. You're just left with 1. If you plug in 1, you're going to get a fraction. If you plug in 2, you're also going to get a fraction. I'm going to plug in 4 because if I did that, the fraction would go away. So negative 1/4 times 4 would be negative 1. And negative 1 plus 1 would be 0. So really with all these that I'm doing, I could write this out if I wanted to, but if you're one of my students, I'm saying you can leave this part out, the red part you can leave out, but you can show the work for it too if you want to. I can see how you would come up with these values without showing the work for this though. So if I plugged in a negative 4, the fraction would also go away. So if I plug in negative 4 for x, negative 1/4 times negative 4, negative times a negative will be positive, and then 1/4 of 4 is just 1. So you have 1 plus 1, that is 2. So if I graph this, I'll do this one. I'll say this one will be in blue, so I'll circle that in blue there. 0, 1 is that point right there. 4, 0 is that point right there. And then negative 4, 2 is that point right there. And if I graph a line connecting those, should be done. So there is my line going through those dots. All those are collinear. I'm going to put arrows on the edges, or on the ends. I'm going to make sure my graph goes all the way through from edge to edge, and I'm going to label that with a number 14 next to that. That represented number 14. This one I will use purple. So this one's already solved in terms of y. So I don't need to solve for y. It's already been done for me. This one, if I'm going to make an xy table though, if I plug in some values, this one's actually, I think, considerably easier than this one because there's no fractions to deal with. If you plug in 0, 3 times 0 is 0, minus 2 is negative 2. If you plug in 1, 3 times 1 is 3, minus 2 is 1. If you plug in 2, 3 times 2 is 6, minus 2 is 4. I could have plugged in negative values if I wanted to. I could still plug in 3, but that would be 7 and it would actually go off the graph. So I'm going to stick with these 3 points. So this is 0, negative 2 right there. 1, 1 would be right here. And 2, 4 would be right 2, up 4. Connect those with a straight line. Make sure you go edge to edge and then put arrows at the ends of those and you're going to be good to go. And just make sure you label it as well. So this is number 15. Taking a look now at numbers 16 and 17. This one is a different method. So that was method 1, the x and y table. Method 2 is the x and y intercept. For the x and y intercept, we thought of it like this. The x-intercept was where the y value was 0, and the y-intercept was where the x value was 0. If you think about the x-axis here being the x-intercept, the y value is always 0 anywhere on that axis. If you think about the y-intercept, the x value is always 0 anywhere along that axis. So that's why these numbers make sense to start. for the x-intercept, if I plug in 0 for y, 4 times 0, that would just go away. So I can think about covering that up and just thinking about what makes this true. What makes negative 3 times x equal to 12? What could you plug in? Negative 3 times negative 4 would be positive 12. Likewise, we can do the same thing for the y-intercept. Plug in 0 for x. This part then goes away. And what makes that true? 4y equals 12. 4 times 3 equals 12. So a 3 could go in right there. So if I plot those points, negative 4, 0 would be right here. 0, 3 would be right here. And I can connect those with a straight line, and I'm going to be done. So let's go using the blue there. Go back to blue. And looks like I'll need to rotate that just a little bit. So make sure this would not be a totally acceptable graph because that's not going right through the point. We want to make sure that it actually goes through both points. That's a little better there. So I've got that. I'm going to draw my arrows at the end and make sure I label that with 16. And then in purple, I'll do this one in purple. Same idea. X-intercept is where y equals 0. Y-intercept is where x equals 0. If I plug in 0 for y, this part drops out. And then 6 times 1 makes that true. 6 times 1 is 6. If I plug in 0 for x, 6 times 0 would be 0. This part would drop out. Y equals 6, 6 equals 6. So that makes that true. And so it looks like 1, 0, that would be right here. 0, 6 though would go off the graph, but it's really close. This is 5, so I'm just going to go up using the same scale, going up consistently the same amount. That would be my next point. And if I connect those with straight line, use purple for that. There we go. It's going to look like that. Oh, that was a little bit off. Let me make that a little better. It's going to look like that. That's better. Okay. So that goes through both points there. I'm going to label that with a 17. From there, third method, point slope form, graphing from point slope, where you're given this as your equation. Y minus y1 equals m times x minus x1. The point is that, the slope is your m value. So if we look at this equation right here, the form itself has a minus sign in it. So the point is going to be the opposite of what you see next to the variable. So the point is actually 2, not negative 2, because the form has the minus sign in it already. So this one, my point for point slope form is going to be the opposite of what I see there for x, positive 2, the opposite of what I see here for y, positive 3. My slope is the value in front of the parentheses. That's the negative 1/2 value. So if I use this to make the graph, I have to start somewhere. I have to start at the point. 2, 3 is where I start. From there, negative 1/2 I can think of as negative 1 over positive 2, or I can think of that as positive 1 over negative 2. Both of those things equal negative 1/2. So if I use this, negative 1 over positive 2, I'm going to go down 1 and right 2. I go rise first, up or down first, and then run is left or right. So if I use that one, go down 1, right 2. If I wanted to use this one instead, I would go up 1 and left 2. Positive is up and left is negative. So connecting those points will give me my line. So let's do that here in blue. And that would be a good line right there. Go edge to edge, connect them up. You got 18 right here. Number 19, we're using point slope still and doing the opposite of what we see. So on this one, the point is going to be the opposite of positive 2. It's going to be negative 2. This one, the point that goes with the y, is a negative 3. The form, again, has the minus sign in it, so it better be the opposite of what you see down here. The slope is going to be the value in front there, which is 2, which we can think of as 2 over 1. That's really the better way to think of it when you graph. So -2, -3, that's that point right there. And 2 over 1, we go up 2, right 1. That pattern would continue, so you could make some more dots if you wanted to. You wouldn't have to draw all these. If you thought of 2 over 1 with negatives, that would be -2 over -1. Those two things equal each other. So you could also do this. You could also go down 2 and left 1. That would also work to get you a new point. Notice all those points are collinear. They're on the same line. That means we are pretty confident that we did that right. So let's draw a straight line through all those points. Put arrows at the ends and label it appropriately. This is number 19 on that one. Moving on to number 20 now, slope-intercept form. The final way that we learned about slope-intercept form was y equals mx plus b. And m is your slope value. The number in front of the x could be positive or negative. And the b was your y-intercept. Could be positive or negative. So on this one, on number 20, your slope, the number in front of the x is -1/3. Your y-intercept, the number after the x, is -2. That's your slope and y-intercept. Again, you have to start somewhere. You got to start at a point, and our point would be the y-intercept. So on the y-axis, go down 2. There's where you start. And if your slope is -1/3, that's either this or this. You can put the negative sign with the top or the bottom. If I put it on the top, I go down 1 and then right 3. If I put it on the bottom, I would first go up 1 and then left 3. Connecting those points will give me my graph for the line. Looks like that looks good. Putting arrows at the ends there and labeling that with a number 20. 21, already in slope-intercept form. It looks like on this one, my slope, the number in front of the x is -2, which is the same thing as -2 over 1. And the y-intercept is 3. So I'm going to start at the y-intercept, go up 3. There's a point on the graph of that line. And if the slope is -2 over 1, I can think of it like that or like that. If I think of it like that, down 2 and right 1, I've got a new point. Down 2 and right 1, the pattern continues. If I think of it like this instead, up 2 and left 1. If I connect all those with a line, I'm done with number 21. So there's a good line. Let's label that with number 21. And let's move on from there. So number 22. Now we're going to graph lines that are perpendicular to other lines. Graph the line y minus 1 equals -2/3 times x plus 3. Which one of these four forms does that look like? Definitely looks like this one to me. It looks like point slope form. So I want to use point slope to figure this out, since this is already in point slope form. What is the point that goes with this equation? Well, it's the opposite of what I see next to the x and the y. So it's -3 for the x value, and it's a +1 for the y value. The slope is going to be of the original line here, -2/3. So I'm going to go to -3 and up 1. There's where I start. -2/3. If I put the negative on the top, I'm going to go down 2 and right 3. If I put the negative on the bottom, I would go up 2 and left 3. So there's a line. I'm going to keep that pattern going, down 2 and right 3, and connect all those with a straight line. So that's my original line. My other line is supposed to be perpendicular. So I'm going to label this as the original. Make sure you're labeling if you have more than one line on the graph. The perpendicular is going to contain this point. So let's start here. I know I have to start there. -1, 1. That is going to be a point on the graph. And if it's perpendicular to this line, perpendicular lines have opposite reciprocal slopes. And so we're looking at this. The opposite reciprocal of negative 2/3 is going to be positive 3/2. We flip the fraction, and if it's negative, we make it positive. If it's positive, we make it negative. So the slope of the perpendicular line, or the perpendicular slope, would actually be negative, or would be positive 3/2. So we're supposed to find the equation for this line. I can graph this line though from here, because I know I have to start here, and then 3/2, I'm going up 3 and right 2. If I went down 3, it'd be like a negative 3. I would have to go to the left 2 to make sure it's still equal to 3/2. So down 3 and left 2, I would have another point. Down 3 and left 2, I would have another point. All those points would be on the graph. And if I connect those, it looks like that. And I'll put the arrows at the ends there and label that with the perp. This is my perpendicular part. I still need my equation though. I haven't found that yet. But I have a point for the perpendicular line. I have a slope for the perpendicular line. That slope is 3/2. That point is negative 1, 1. So from here, we have this point, we have this slope. My y minus y1 would be y minus 1 equals 3/2 times x minus a negative 1. That's y minus 1 equals 3/2 times x plus 1. And for these ones, I'm going to say that you do not have to solve for y, because if we're graphing, we can graph directly from this form. So on these graphing ones, you can leave your equation, final answer, in point slope form. This is the equation of the perpendicular line. From there, let's check out number 23. So graph the line y equals 4. Let's start with that in blue. This is where y always equals negative 4. It doesn't make a difference what your x value is. The y value is negative 4. So if x is 0, y is negative 4. If x is 2, y is negative 4. If x is negative 1, y is still negative 4. Notice if I connect these dots, I'm going to have a horizontal line there. So connecting the dots, there we go. Got my horizontal line. Anytime you have y equals, that is going to be a horizontal line. Anytime you have x equals, you can probably guess what that would be. That's going to be a vertical line. So if we're going to draw the line that is perpendicular, we know it's going to be an x equals equation, because x equals vertical will be perpendicular to a y equals, a horizontal. And it's got to be perpendicular through this point. So negative 2, 2 is right there. And a perpendicular line is right there. Let me make that a little more precise. Still not quite where I want it to be. Wow. Just one of those problems. That's close enough. Okay, so that's right there on that vertical line, or that vertical line passing through the point negative 2, 2. And if they're perpendicular to one another, they are going to have, in a sense, these are opposite reciprocal slopes, but this one is an undefined slope, and this one has a slope of 0. So with vertical and horizontal, you can just draw them in. If I said parallel here instead, we would have another horizontal line, but I'm saying perpendicular. It's got to be a vertical. It's perpendicular to a horizontal. To give the equation for that line, this is going to be x equals negative 2. This is the equation of the perpendicular line. Because if you look here, this is where x always equals negative 2. It makes no difference what your y value is. x is always -2 along that line. Let's check out number 24 now. So graph the line with x-intercept -4, y-intercept 1. So let's start with that. So x-intercept -4, it's that point right there. Y-intercept is 1. It's that point right there. And if we graph that line, we're going to connect those with a straight line. So if that pattern would continue up 1, right 4, I'd have another up 1, right 4. So I know that's got to be on my line as well. I want to be precise with this. There we go. That looks good. And let's label this as the original. I think I forgot to do that on the previous one, so I'm going to go back to that one and do that here. So this is my original, and this is the perpendicular. And so from there I'm going to do this one parallel. That means with parallel we have the same slope. On this one, the slope of the original, I mentioned it already. If you caught that, I'm not sure. So the slope of the original, think rise over run. They don't give it to you in the form or the information up there, but you can think rise over run and easily figure that out. We're going up 1, right 4, up 1, right 4. So +1, +4, +1 over 4. If it has the same slope, that means it's going to also be for this parallel line through 3, -2, that is over 3 to the right and down 2 there. That means it has to have the same slope there. If I go up 1 and right 4, I go off my graph, but remember 1 over 4 is the same thing as -1 over -4. So you could also go down 1 and left 4 and have another point there. Down 1 and left 4, have another point there. And if I connect all those, it's looking like that, and that would be my parallel line in this case. And we still need to come up with the equation for that. So the equation using point slope form, so the equation of the parallel line, that's my symbol for parallel. The upside down T here was my symbol for perpendicular. So the equation of the parallel line, that is going to use this point, the point right here, 3, -2, and the same slope as my original line. So the slope is 1 over 4. So if I use point slope form, y minus -2 would equal +1/4 times x minus 3. This would become positive. If you wanted to write that right away, that would be totally fine. This would be an acceptable final answer for these graphing ones. Leave it in point slope form is fine because you can graph directly from there. Number 25, graphing the vertical line that passes through -4, -1. -4, -1 is right there to start. So it's vertical. It's passing through that point. So that means I would have something like this. With arrows at the edge, at the end, that's the original line. And then for the other one, it's going to be perpendicular. We know vertical and horizontal are perpendicular, so this would have to be a horizontal line. It has to pass through 3, -2. So that's over 3 to the right and down 2 like that. And it's got to be horizontal through that point to be perpendicular. So let's draw a horizontal line in through that point like that. Put arrows there. This is perpendicular, so I'll label that as the perp. And the equation then for this perpendicular line, something always equals -2 here. What is that value that always equals -2? That would be my y value is always equal to -2. So the equation of the perpendicular line is going to be y equals -2. The equation of this one, if you had to find that, it didn't give you that right here, but x is always equal to -4. So if you wanted to label that as x equals -4, you could. be a good little extra practice thing to do. But this is really all I need, the equation of the perpendicular line. And then to end up here, we've got some scatter plot stuff. So for 26, 7, and 8, for each scatter plot, part A, tell whether the data have a positive correlation, a negative correlation, or approximately no correlation. And then B, tell whether the correlation coefficient is closest to -1, -0.5, 0, 0.5, or 1. So on this one, on 26, for part A, to me it appears that there is a positive correlation here. It's not a very strong positive correlation, but it is a positive correlation. The trend is at the data points. It's going up as you move from left to right. So I would say on this one, the line isn't necessary according to what's up here, but I think it's helpful. Part A, there is a correlation, and I would say it is definitely positive. It's going uphill as you move left to right. So a positive correlation for part A. And then part B, if it's a weak positive, that's the 0.5. If it's a strong positive, that's the 1. So this is a weak positive. The data points aren't real close. So it's closest to, of the values that are listed here, closest to 0.5. For 27, it looks like this is definitely a negative correlation. The data is going down. The trend is that it's going down as you move from left to right. And those data points are very close to the line. That means it's a strong negative correlation. Part A, we're going to say that it is a negative correlation. And since it is a strong negative, it's very close to -1. It's definitely closest to that value. So strong negative is -1. Weak negative is 0.5. If it's like this, where there's no real trend to the data, there's no best line of best fit that you could draw in here, this would be no better than this, I would say, really. That's where you run into no correlation. So part A on this one, this is no correlation. And the, that's no. And then the no correlation, that's with 0 as your correlation coefficient. And then number 29, the last one here. The table shows the number Y in thousands of alternative fueled vehicles in use in the United States X years after 1997. So this is actually, this value right here is actually 1997. This is actually 1998, 1999, and so on as we move forth from there. So let's graph this first. It looks like I'm jumping from 0 to 300, and then it's only a jump of 50. So it goes 300 here. So technically, I feel like I should put a little line break in there saying I'm going from 0, skipping a bunch of stuff, and then going up to 300 there. If I plot this point, 0 to 80, that's about right there, I would say. If I'm counting that as 50 for each jump. 1 to 95 would be right about there, just beneath the 300. 322, if this is halfway, it's 25. That's just underneath there, just a skosh. This 395, excuse me, would be right about here. And then 425 would be halfway through there. 471 would be just under halfway in between those two grid lines. 511 looks like that's just above there. And then 548, just a little tidbit underneath 550. So use an equation for the best fit line to predict the number of alternative fueled vehicles in the United States in 2010. So it looks like I need to determine an equation first of all to be able to do that. So I'm going to draw a line of best fit in here that I think is pretty good. We're not finding in this class in Algebra 1, we're not going to find the best line of best fit. We're just approximating it. So I would say this is a pretty good approximation for a line of best fit. I'll go with that as my line of best fit. So the slope of this line of best fit, I need to actually pick 2 points that are on the line. If I pick 2 points that aren't on the line, like this one, that's not going to give me a good equation. So I'm going to pick, this looks like it's definitely on the line right here, this point to me. And I can pick a point that's not actually a data point for the other point. I'm going to do that here. I'm going to use that point right there. That looks like it's 2. 350, and 4, 425. So I'm going to use those 2 points. If you used slightly different points or different points along this line of best fit, but they're actually on the line of best fit, that's fine. That is totally fine, totally acceptable. You may have a slightly different answer, but remember, this is going to just be an estimate for the line of best fit. The perfect line of best fit takes a little more work than what we're going to do. Most of the time people would use a calculator and use a program or a function in the calculator that would figure out the best line of best fit for them. This is 2, 350. So from those 2 points, I am going to find my slope. My slope is, another way to think of that, is y2 minus y1 over x2 minus x1. I can think of it as rise over run as well. But if I use this idea, it's going to be 425 minus 350 over 4 minus 2. This is like my x1, y1 right here. This is like my x2, y2 right there. Simplifying that leaves me with 75 over 2, which equals 37.5. That's my slope. And then from there, I can pick one of these 2 points. I want to pick a line that's actually on the line of best fit, and I might as well go with one I've already picked. So I'm going to pick this one. That looks a little easier to deal with than this one, but I could have chosen that one as well. So from there, I can now use point slope form. I can use y minus y1. Since I know a point and I know a slope, I can use y minus y1 equals m times x minus x1. So my point, I'm choosing this one. My point is 2, 350. And my slope is 37.5. So if I use that and use that in y minus y1, it looks like this. Y minus 350 equals 37.5 times x minus 2. If I distribute that through there and there, I get y minus 350 equals 37.5x, and this would be minus 75. And then from there, I can add 350 to both sides to get y by itself. So I have y equals 37.5x, and this looks like it's plus 275. If I look at that, that's in slope-intercept form right there. Not a final answer, but pretty important. And 275, does that look like it's the y-intercept right there? Certainly does to me. And it looks like we're going up 37.5, so that'd be up to about there every time I go to the right 1. 37.5, and then up to the right 1 again. It looks like that matches up very well with my line of best fit up here. I still need to predict this though. I need to predict after, this is X years after 1997, for the year 2000. This would be 13 years after 1997. So that means, in other words, that X equals 13. You're going to plug that value in to X right here. So if I do that, that looks like Y equals 37.5 times 13 plus 275. And so that leaves me with Y equals, this would be, if I just put all this together, I'm going to put all that together in a calculator. I got 762.5, and that is in thousands up here, so that many thousands. So that would mean, if I write out the whole number, it looks like this: 762,500 vehicles. And that would be in the year 2010, predicted by this equation. So that's my final answer. As needed, please go back and review the ones that you're struggling with. Come in, if you're one of my students, come in for help before or after school during my available times, and let me know if you need help. Be ready for the test. Make sure you're using Khan Academy, other things, other tutoring opportunities to help you out as needed. Make sure you're ready for that next test. Do the best you possibly can. Get as prepared as you possibly can. I'm doing everything I can to help you. Make sure you're doing everything you can yourself to help yourself as well. So I hope you have a great day. Hope you study hard and do very well on the next test. Let me know if you have any questions. If you noticed any mistakes in the video, please comment. If you're one of my students and the first person to comment appropriately on a incorrect thing on the video, I will gladly give you some Wagner bucks for that. Alright, I will catch you guys later for our next review packet or whatever other video you happen to want to watch on here. Have a great day. Bye-bye.